The last item we're going to discuss in section 2.6 is the intermediate value theorem. The intermediate value theorem states if f of x is continuous on the closed interval, we put the word on, the closed interval AB, and K is some value between f of A and f of B, comma, then there exists at least one x such that f of x equals k. So one more time. If f of x is a continuous function on the closed interval AB, and k is some point or some value between f of A and f of B, then there exists at least one x such that f of x equals k. This may be easier to see on a graph. So first thing I want to do is I want to make a generic continuous function. So generic continuous function here, that's A, that's B, this would be f of A, this would be f of B, and it says k is some value between f of A and f of B. So what that means is I have a point k somewhere in between here. And it says if these two conditions exist, one that I have this closed continuous function and that k is in between those two values, there is at least one x between A and B. Actually, I need to add that. At least one x on the closed interval A comma B, such that f of x equals k. So what that means is there is at least one value that I can find an x. So that x, f of x1 is equal to k. That f of x2 is equal to k. That f of x3 is equal to k. Doesn't have to have more than one, but it can have more than one. It says there is at least one. So please go back and make sure you change to add these words on in here. I missed them on the first time around. If f of x is continuous on the closed interval AB and k is some value between f of A and f of B, then there exists at least one x on the closed interval AB such that f of x equals k. We have two hypotheses here. The first one is that the function is continuous, and that the second one is that k is between f of A and f of B. Both of those conditions must exist in order for the intermediate value theorem to be applied. For example, I have the following function. Here's A. Here's B. This is, again, f of A. This point right here is f of B. If the function is not continuous, there may be some k in here that I never touch the function. So that shows you why the graph has to be continuous in order for the intermediate value theorem to hold. Next, let's just draw another graph. This time we're going to keep it continuous. So I have A, I have B, I have f of A, I have f of B. But this time I'm going to put k that's not between f of A and f of B. For example, if I pick a k up here, again, I cannot guarantee that there is going to be some x that's going to give me that value. Yes, I understand that that graph could have done something like this, But there's no way I could guarantee that that function did something like that. I can only guarantee it is if k is between the values of f of a and f of b. So you need to be able to know the definition of the intermediate value theorem, be able to state why an intermediate value theorem can't be used for some values, and then you need to be able to do some application problems with the intermediate value theorem, which will be the subject of the next video.